Hello and good morning for those of you in a morning time zone. Uh, my name is Larry Garfield. I'll be your presenter today. Hopefully, that's not too disappointing. If you were expecting something else or someone else, then I apologize. We're going to be talking today about cloud friendly applications. If you'd like to follow along at home, here's a link in the chat where you can do so. My name is Larry Garfield. You may know me online as Krell. If you want to make fun of me on Twitter during the talk, that's where you do so. I generally encourage that. I am starting next week, a staff engineer for Typo3. I actually come mostly from the PHP community, not from the Java community. But what we're talking about here is fairly language agnostic. Yeah, been around the PHP community for a long time in a number of different roles. I've also written a number of books on software development in PHP. And I, until recently, worked for Platform SH, which is a continuous deployment cloud hosting company, on which much of this talk is based. Just from my experience there, working with different applications. So let's talk about clouds. Wrong clouds. I'm talking about cloud hosting here. Like, as I said, I worked at Platform SH, and part of my job there was working with a lot of different applications to make them play nicely with Platform's cloud-based hosting solution, which meant I got to work with a lot of different applications, some of them very good, and some of them, if you can't see anything nice, don't see anything at all, so I won't mention those. And this gives me a very broad perspective on what works and what doesn't in modern hosting. Now, why does this matter? Well, because cloud-based hosting is where things are going. Everyone's talking about cloud this, cloud that, cloud hosting, cloud native. That's where everything is moving these days technologically. Okay, what does that mean? What do we mean when we say cloud? There's actually two different answers to that question, depending on what exactly you're talking about. There's cloud computing, and then there's the cloud. These are not the same thing. They have two different answers because they refer to two different things. The cloud is a marketing term that means someone else's hard drive. It goes back to the 90s, actually a bit earlier, where the network between two computers was represented by a big pink cloud in block diagrams on people's marketing slides to say, hey, and then this problem goes away because the cloud takes care of it. It just stuff. This is a business model. It's not a technological model. It is simply outsourcing by another name. We're not really going to be talking about that much here, but it's important to understand the distinction between someone else's hard drive, the cloud, and cloud computing. Cloud computing is a style of software architecture and software deployment that abstracts away physical infrastructure. It is usually implemented on the cloud, meaning a dedicated company that does this kind of management, but it doesn't have to be. You can absolutely build a cloud computing environment on your own hardware in your own closet or even on your own desk. The core idea here is to have logical systems, logical computer systems that exist in software, not in hardware. So you have a logical computer system you can work with as though it were a computer that is divorced from physical box sitting on a desk or on a rack somewhere. And what this enables then is disposable application design. You've heard the phrase before, likely, that you want your systems to be cattle, not pets, so that you can just replace them. What this enables is for you to do the same with your application instances. Your application instance in cloud computing is not a single copy of the code running on a server that you keep maintaining and updating and so on. No, your application instance is a snapshot of your code at a given point of time. And when you want to update it, you delete it and install the new one instead and just rebuild from scratch, which gives you a lot of flexibility and a lot of new options for maintaining, deploying, and managing your applications that didn't exist before. But not all applications play nicely with that model, especially older ones that were written on the assumption that you would have just a single server running somewhere and that's it, don't always play well in this type of environment. So what is it exactly that makes an application cloud friendly? What makes it play nicely when you have disposable instances rather than artisanal handcrafted servers? As I said, I've worked with a lot of different systems and I've gotten to see some that do it well and don't. And so these are some guidelines and rules of thumb, essentially, for architectural decisions to make your applications play nicely in a cloud-based environment. First of all, and most importantly, split your code from content. Seems obvious, but you'd be amazed how many systems don't get this right. Now, what do we mean by code and content? Code means stuff provided by the developer. It could be source code, it could be configuration files, could be any number of things, but it is provided by a developer. It is carefully tested before it is deployed because we're all doing proper automated testing, right? Its canonical official version lives in version control of some kind, usually Git, but could be other systems, because we're all using version control, right? And at runtime, it is read-only. The code does not change at runtime. Why does the code not change at runtime? Because code changing at runtime is a security hole, by definition. If your code can change independently of version control, then you lose security, you lose auditability. You have, if someone attacks the system and can get in through one vector, they can overwrite code on disk, and then your whole system is owned. Those are all bad things. So your code is read-only at runtime, at the disk level. Content, meanwhile, is provided by end users. Could be an administrator using the system, could be users posting comments, whatever it is, it's provided by users of the system. Usually ad hoc, without any formal testing and auditing process, although there might be one. And its canonical definitive version lives in a database of some kind or on a file system. Could be an SQL database, could be Mongo, could be a local file store, could be S3, doesn't matter. But whatever it is writable at runtime. The content does change as the system is running, unlike code, which does not change. That means the file system where your code lives and the file system where your content lives need to be different, because you want the code, the physical disk the code is sitting on, to be read-only. And you want the physical disk that your content is living on to be writable. This means any given directory in your application needs to be either code that comes from version control or data, content that does not come from version control. Do not put both of those categories of stuff into the same directory. If you do, you will have problems. It's amazing the number of systems that get this wrong. Remember, your application is disposable. That's the point. Your data, however, is not. If your data is disposable, you don't actually have a production system yet. You're still testing. But once you are in production, this is kind of the workflow you're going to be working with. You have your development environment, your local laptop or whatever, and you're working on code, making updates, push and pull to Git. And then at various times, you will take a snapshot of what is in Git and run that through a build process. And that build process could be downloading additional dependencies. It could be compiling jar files or WAR files, or compiling TypeScript to JavaScript, compiling Sass or less into CSS, all kinds of things that turn stuff in version control to thing I actually run. And that can be all kinds of different operations. The output of that, though, is some production artifact. And that artifact is an instance of your application, which you're then going to install into production, where there is already data waiting for you of all the content that has existed up until that point. At some point, you're going to take a snapshot of the data and download that to your development environment or to your staging environment to use live data for testing. But that is a different pathway. And that pathway begins in production and ends in development, whereas the pathway for code begins in development and ends in production. And nothing goes back around that loop. You really don't have an in-between option between dev workflow, code workflow, and content workflow. So make sure that those things are very, very clearly divided, and you don't have anything that's kind of sort of in between, or things that are a little of each in one directory. You will have problems with those. Okay, that's all well and good. How about configuration? Is configuration code or is it content? Well, is configuration something that the developer controls or something that the user controls? Is its canonical version in the in version control or in the database? Which is the authoritative version of that? It could be either. Either of these is a completely valid answer. It's usually not an issue for bespoke applications because in that case, it's a custom built application. So configuration is stuff the developer puts into XML or YAML or JSON or whatever that just configures the application or your container or whatever. And so in that case, configuration is code. But for a pre-made application, especially a content management system or an ERP or a blogging system, in a lot of cases, the whole point of those applications is to let people configure it through the UI in some fashion, which is cool and useful and means that that configuration is content, not code, because it lives in the database and is entered by a user, which means you can't use a code workflow for it because it is not code. Again, either one of these is okay. You may have stuff that's a system where some of your configuration follows one workflow and some follows the other workflow, and that's fine. But you need to be clear which is which because you can't mix and match. You can't have something that is both code controlled and data controlled because which one wins? It's not an easy answer. The most robust answer to this I've ever seen is in the Drupal CMS in the PHP world. In Drupal's case, as of version 8, all configuration canonically lives in the database, and you configure it through the UI. However, it is stored in such a way that you can cleanly export all of your site's configuration to YAML files, to a directory full of thousands of YAML files that are an export dump of your configuration, which you can then commit to Git, push, pull, whatever you're going to do with Git, like code. And then in production, you push a big red button that imports all of those YAML files back into the production database, overriding the configuration that was there. And now your site has new configuration. This works. It is horribly over-engineered. I'm making it sound very simple here. There are thousands of annoying little edge cases in that system that make everything really, really hard. 98% chance you do not need something this complicated. Instead, just look at your configuration, decide, is this owned by a developer or is this owned by end users, and commit to it being one or the other. Either one is a fair answer, but it has to be one or the other. Just kind of decide which one it's going to be. Next point. What happens at runtime stays at runtime. What does that mean? Well, we said before, you're going to deploy a new version of your application image to data that is already there, which means the data and related services like your database or your search index and their data are already waiting for you in that environment. Your application exists separate from that environment and needs to be able to plug into separate environments too. For example, dev stage prod. If you have a staging server, that is a different environment than production, but you want to use the same application image. You want to use the same application artifact to plug it in there, which means the application now needs to work in both production and staging without modification. You probably have a test server of some kind, or ideally several test instances on different branches. Because, well, everyone has a testing server, just some people are lucky enough to have a separate production server. So you want to have a separate test environment from production. If you're doing something with auto-scaling or multi-head, then your application may have 3, 4, 5, 12 instances running all at the same time, talking to the same data, and that number may be dynamic as traffic changes. So your application needs to be able to handle any environment configuration it could be in, which means it needs to have no knowledge of the environment on its own. You cannot hard code any environment specific information into your application because it's environment specific. It's going to change. It will be different. This also means, as a side note, that any updates to your application involve a restart. They involve turning off the application, deleting it, putting in a new version, and starting it. If your application takes 2 seconds to boot, cool, that's really easy. If your application takes 5 minutes to boot, which some older Java Tomcat applications do, I've seen Java applications that take several minutes to start up, that's not going to fly. That's 5 minutes of downtime every time you want to make an update. If, on the other hand, your application takes a second or two to update, then just temporarily blocking incoming requests, holding them at the edge router, upgrading the application, and then letting requests in again, users don't notice any downtime. They say, oh, this request took 3 seconds instead of 100 milliseconds once every so often. Whatever. The way to solve this is dependency injecting your environment. By that, I mean database credentials should not be in your code or version control anywhere. They are environment specific. And database in this case also means any other services you're talking to, your cache server, your index, search index, and so on. Any API keys that you may have. You really don't want to accidentally be using your production payment gateway keys in testing. Don't ask how I know that, but your API keys should be environment specific. Any paths on disk are environment specific. Now, the relative path from your application root to other files, that you can hard code in, but you cannot guarantee that the path to your application root is the same on your laptop as it is on the production server, as it is on the 3 different testing servers, which are all ephemerally created using containers. The same is true of domain names. Your production environment is going to have some domain name. Your test server is not going to be running on the same domain. It kind of can't. So your application needs to not have domain names hard-coded into it. Ideally, you're working with a cloud hosting system where every branch can be a test environment, which means you have an arbitrarily large number of possible testing sites with their own domains. You can't even hard code in, prodexample.com and testing.example.com because there could be 17 testings instances at the same time, all with their own domain name. You cannot hard code these things in the code or really in the database either. If they're in the database, then guess what? You clone the data from your production site to your staging site, and now all of those entries in the database are wrong. And that's not good. How do we solve this? Environment variables. One of the oldest parts of the stack, environment variables. They've been around in Unix since the beginning. Different languages have different APIs for it, all the same thing. Sometimes there's wrapper libraries as well. Cool, whatever. But all environment-specific configuration gets injected this way, which is kind of an interesting problem because you don't necessarily control what those environment variables are going to be called on a given host. Your application may expect db_URL, but one host may give you database_URL. Another host may give you db name, db user, db password, and so on as separate environment variables. Your application needs to be able to deal with that, which means no matter what, you need to have some place to put glue code for any given host because there is no standard in this department. So you need some way, somehow, to translate the host's environment variables into your application's environment variables. It's very simple logic generally, but you need somewhere to put that. As an example, at Platform SH, we have a series of utility libraries that just wrap environment calls and put a nicer veneer on top of them to make it easier to call getEnd and deserialize some of the values that we have stored that way. So in the case of if you're using Java Spring, then you load up a the platform API library. You call get credential for the database service, format it for MySQL, cool. And now you've got a MySQL database you can then go and do stuff with. And when you are on a new environment, you'll get a different set of credentials. And so you'll get a different database that you connect to for a different environment. And the rest of the code is no different. If you're writing in Kotlin, cool. Same library works on Kotlin too. It's one of the nice things about Kotlin. If you're in JavaScript, there's one for JavaScript that talks, in this case, we're hooking it up to Express. So same thing, grab the MySQL connection, get the credentials out, tell it the port to listen on, and so on. If you're in Go, same idea. We've got a Go application, a Go library. It wraps things up that way and just sets it as a package variable. Details will vary by language. Details will vary by host. The point is, the details vary. So your application needs to be built on the assumption that you have somewhere to put this kind of glue code. It's small, but it has to live somewhere. Okay, great. What about local development? Because you're not going to replicate your entire hosting platform on your local environment, probably. The standard answer there, .env files. There are .env reader libraries in every language, usually several that you can use. The idea of .env files, if you've not used them before, I'm not exactly sure who was using them first. You have an application that reads from the environment, but you also have a file called .env on disk. And then on application start, it checks, all right, is there a variable defined in .env, it's just a key value file, that is not defined in the actual environment variables from Unix? If so, then read that instead. So I can have on my local system a just .env file that I put in db URL equals db password equals and so on and so on, payment gateway key equals. And in my local environment, those values will get used and they will talk to whatever my local development system is. And the application is fine and doesn't know the difference. And that's good, but that is for local only. Do not ever put your .env files into Git. Your .env files are for local. They belong in your Git ignore. In production, you read from actual environment variables. Do not put .env files with actual credentials on disk, and certainly do not put them in your version control. And also, do not put non-environment specific stuff in there. Application name or the main admin user or other things like that are just application configuration that's going to be the same in every environment do not belong in environment-specific configuration. This is a separate pool of data. It needs to be managed separately. Do not mix the two. This also applies to trusted domains. A lot of applications have a setting where you can say only accept requests for this given host, which helps avoid security holes where you can cache poison by sending a request to a server with a bad host header. So if your host's header says evil.com, then if your application accepts that, it may then use evil.com to generate its own URLs. And then what gets cached is a page that has a whole bunch of links to evil.com/whatever. And great, you now have a cross-site scripting attack. Therefore, your application should be configured to only accept requests from the domain that you are running on, which is going to be different in production versus staging versus testing versus the other testing. That also needs to be injected from the environment through environment variables. This also means if you have static configuration files of some kind that do not have the ability to be modified at runtime, by looking at the environment, that's not going to fly. They make overriding harder, they make testing harder, and you now have no place to inject this information. Very common for older applications that just have a static YAML or ini or properties file that you have to configure statically. That is a no-go. That doesn't work in a cloud environment. Stop doing that. Fundamentally here, your application should be told about its environment, not hard code or assume things about it in its environment. The same way you want classes and services to be dependency injected with their dependencies for testing purposes. Exact same principle applies. Of course, sometimes you need to ask the user to configure connections that are environment specific, and that gets problematic. First of all, well, just don't. Doing that through the UI is a bad idea, except for when you get to installers, because, well, everything needs an installer of some kind. What does an installer usually do? Well, step one, it asks for database credentials, and then some kind of basic site information, and writes those database credentials to a config file of some kind, and then it populates the database with the initial tables and setup data and so on, and then writes that basic site info you entered out to either a config file or to the database, and you're done. And that is not going to work on a cloud environment because of all that write to file part, which you can't do, as we said, because you want that to be read-only. Also, most of this you don't actually know. The user should not know what the database credentials are. They should be able to change and get rotated without having to update the application, without having to touch code. So if this isn't going to work, what do we do instead? Better approach for an installer, and I encourage everyone to do this because not enough systems get this right. Pre-include the connection glue. Have the installer look for data in the environment. If you don't know what the host is going to be, make sure that there's a place for host-specific glue to get put in before you actually run the installer. And then the installer can check and say, oh, I already have database credentials there from the environment. I'm just going to skip over that step and not even ask the user. So you hit install. Oh, look, database is already there. I'll use that. We're moving on. And then you don't actually download any code from the installer. Some installers try to download additional code as part of the installation process. That will not work in a cloud environment. Download happens in the build step beforehand when you're building that artifact. You can download data, like translation files that get stored in the database or sample data. That's fine. But code needs to already be there and not get downloaded on the fly. That also means applications that do self-update, not going to fly, because then, well, are you updating it through the UI? Or are you updating it through version control? You can't do both. You have to pick one or the other. And a good application will either have two modes that are mutually incompatible and let you use one or the other, or just be updating code through version control. But having an application that you can only update in place is a security hole. Period. Full stop. No exceptions. You also need to avoid lock-in. And at this point, we're talking more about the cloud than about cloud computing, but it is a related topic. You always need to be able to take your business elsewhere. You need to keep your providers honest. Whoever you're hosting with, whatever cloud computing system you have, whether that's an in-house team or AWS or Platform or Heroku or whoever, even if you like them, even if everything is working fine, you need to keep them honest by being able to take your business elsewhere. If you are relying on a service that is part of your application but is a third party, guess what? Google has killed over 227 different services. If your application was depending on Google Buzz or Google Plus or Google Web Accelerator or whatever, and they just turn it off because it's in their best interest to not bother maintaining it, you are now dead. You need to have your best interest in mind, and that means insulating yourself from any third-party service that you are depending on, including your host itself, as well as especially any of these other services, because they may disappear out from under you. Their terms of service may change. You have to be prepared for that. The way to do that is to use free software. Just stick to open source, stick to free software, stick to things that are replaceable. Not because it's necessarily technically superior, in many cases it is, but if your host goes out of business, or they change their pricing in a way that doesn't work for you, or they change their terms of service in a way that doesn't work for you, then you need to be able to download your data, pick it up, and go somewhere else. Not because you want to be able to host an application yourself, but you want to be able to pay anyone else to. If your application cannot run without AWS Lambda, guess what? You are now 100% dependent on AWS Lambda, and Lambda could destroy your business overnight at any time. So what's safe? All of your standard open source tools you're familiar with. What's not safe? Any of the proprietary hosted versions that you cannot port off of very easily. I'm not against using third-party services. That's fine. I'm against using proprietary services that you cannot replace. If you're building your system on Postgres, then fine. If you can download your database and then upload it to some other host, you can now pay anyone to host Postgres for you. And that keeps them honest. That gives you an escape hatch. That means if you need to migrate, you don't need to re-architect your system. Do not rely on third-party services you cannot easily replace with someone else. That is a ticking time bomb that will blow up in your face. It has blown up in the face of a lot of companies. You don't want to be one of them. And finally, no talk about the cloud would be complete without talking about microservices. Because, well, clouds enable microservices, right? That's what they're for. I mean, microservices and clouds go together like peanut butter and jelly. Great. What's a microservice? Well, according to Wikipedia, there is no industry consensus yet regarding the properties of microservices, and an official definition is missing as well. Thanks. The best consensus, somewhat, based on Martin Fowler, who coined some of the terms, and Wikipedia together, microservice design is built around single-purpose components that talk to each other over dumb pipes. HTTP, IPC, gRPC, some kind of generic protocol, not like MySQL has its own protocol and Postgres has its own protocol. These are generic public formats. They are built by separate teams. Each component has a separate team that builds it, and they have independent releases. So you can release a new version of your user service without having to think about your payment gateway service. And you can update the payment gateway service and not have to worry about the user service. They're separate teams working independently, to the point that they are all third-party services, just like we were talking about before. That might as well be Google or the team down the hall or the team across the country. And the fact that you all get paid by the same company is irrelevant from an architectural perspective. Now, this does have a number of benefits. It means that each team and each system can use different tooling and a different language, even depending on what you're doing. You can implement your web front end in PHP and your user backend in Java and your payment gateway in Go, and everything works fine because they're all just talking to each other over HTTP. It means you get small, focused teams for each component. Every component has its own product manager, its own developer, its own architect, its own UX person, if necessary. You get very strong separation of concerns because the user stuff goes over here in this code repository and the product stuff goes over here in this completely different repository. It's going to keep those two separated. It also means you can scale them separately. If you need to throw more hardware at your web front end, okay, fine. You can do that, and it doesn't affect your payment gateway at all. You want to rewrite your user service from Node to Go because reasons, you need the more performance, then cool. That does nothing to your payment gateway. Most of these benefits, though, revolve around the fact that you have different teams. Microservices are not a technical architecture, they are an HR architecture, leveraging Conway's law. An organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. This has been borne out in other testing. Microservices are specifically using this fact to design your system architecture by saying, we're going to split the development team into 4 pieces that don't talk to each other. And so we'll end up with 4 systems that don't talk to each other, except through very controlled pathways over HTTP or whatever. That is the point of microservices. If you are simply having one team spin up 5 different repositories all at once and trying to keep them in sync, that's not microservices, that's a mess. There are a lot of drawbacks to this process. The biggest one, network latency. It takes a nanosecond to call a function in the same application. Moving that same function call from one computer to another is now in the microsecond or millisecond range, orders of magnitude slower. And you have a lot more points of failure, points plural here, because the potential for a function call to break calling another function call with just random entropy is like 1 in a trillion. It's basically looking for sunspots and gamma radiation. Calling from one computer to another over a network, there's only about 15 pieces of hardware that could go wrong, plus all of the software managing it that could go wrong. You're dealing with orders of magnitude higher potential. You could need to assume 1 out of every 1,000 requests is just going to die mysteriously for no good reason, and you have to build for that. If you need to refactor something and move code from the payment gateway into the web front end or vice versa, it's substantially harder because it could easily be in a different language. So guess what? You can't just move the code around. You can't just refactor it. You have to rewrite it completely in a different language. It also means you now have to worry about API versioning. If you've done work in web APIs with REST, then you know that there are 3 different ways to do API versioning with REST. All of them wrong, all of them broken. This sucks. But you now have to deal with that because when you introduce a new API for your payment gateway, that has not updated the user backend yet. It has not updated the web front end because there might be multiple web front ends. And so you now have to deal with that, having multiple versions of your payment gateway API running at the same time for who knows how long. You also need more staff because every team needs their own developer, or every team needs their own project manager, every team needs their own UX person. You don't want to share staff because then you are back to having a big blob. There's also per request overhead, depending on the language. There's more of an issue in PHP, but even in a system like Java or Go, you still have to go through the effort of running your router multiple times on every request because you're running it once in every system that you talk to. And it's really, if one of your microservices going down means the others don't work, then it's not a microservice. It's a distributed monolith, which means all of the downsides of monoliths and all of the downsides of a distributed system and none of the upsides of any of them. So if you're not Google, Amazon, or Netflix, the odds of you actually needing microservices are pretty small. So if you're not Google, Amazon, or Netflix, what should you do instead when your application is starting to get big or you want to be able to scale it? A better alternative is what I like to call a multimodal monolith. What is a multimodal monolith besides being a mouthful to say? I can't believe I got through that. A multimodal monolith is built by a single team. So you have one set of developers building this thing. It's built in discrete components because all good software these days is built in discrete components that run together, cooperate, but they all deploy as once. They do not, you don't have separate teams doing their own deploys. An update updates all the pieces at the same time. Usually you'll do it all in a single language. It doesn't have to be. It was common for a long time to have an application that was PHP based but had a Node or Go worker on the side. That's fine. But usually they'll all be built in the same language. And they can share data stores. Normally in microservices, your user backend could be using Mongo and your payment gateway is using Postgres, and the user service has no way to contact the Postgres server that the payment gateway is using. And the web front end doesn't talk to either of them. You're just talking over those standard public pipes. With a multimodal monolith, all the pieces talk to the same SQL database. That's fine. Odds are everyone here has already done this at some point. What are some examples of a multimodal monolith model? And that's a mouthful. Cron jobs. You have some part of your application that uses all the same domain code, all the same application code, but runs sometime later. So you have a cron job that runs next to your application, reuses 3/4 of the same code, if not more, but it's a separate entry point that does a different thing. Or queue workers. You have a task come in that you need to do that you don't want to block the web request for, say sending a bunch of emails, for example. Toss those into a queue, and then you have a queue worker sitting there that chews through that process and takes care of whatever those are separately and doesn't block the web request. Great. A lot of applications have a separate admin app. Could be a separate front controller in something like PHP. It could be a completely separate compiled application that shares 3/4 of the same code if you're in Java or in Go. That's fine. And you can put that on a separate container too. Some applications that didn't start with having a public web API add one later at a separate entry point. That's a separate application that reuses 90% of the same code, but runs as a separate application. You could do this in a single language. You could do this in multiple languages. You could put these all on the same container, but you could also put them on different containers. You have the same application image you've built, the same compiled image you've built, and you spin it up once in end user web mode, and you spin it up a second time without recompiling in admin mode, and a third time for running a queue worker that doesn't even accept HTTP requests. It just does queue tasks. And if you need to scale the web application, great, you just add more of that instance, but not the admin instance. So now you can scale independent parts of the system on their own, add multiple workers, add multiple web front ends, and the others keep working. If you're getting a lot of traffic on your user front end, your admin is a separate container, possibly even on separate hardware, so it's not going to get overloaded. What do all of these have in common? They all happen on an asynchronous boundary. Any given request only touches one of these services. A given web request is going to hit the admin system and not anything else. That may trigger off some queue processing, but that just goes to a queue service, and then the worker attaches to that separately. So you only do the work needed to respond. You have no per request inter-service communication. This gives you a lot more reliability and a lot more flexibility. It is more complex than just putting everything in one giant monolith, true, but you get a lot more flexibility and a lot more power for a lot less effort than rewriting the whole thing in microservices and having all of those complexities. I would venture to say for 90 to 95% of situations where people try to use microservices, they would be better off with this. They'd be better off just having a single application with multiple entry points that they can run multiple times. And then you only have one code base to debug. In summary, then, don't assume things. The way to be cloud friendly is to not assume things. Do not assume the environment your application is going to run in. Do not assume the number of webheads it's going to have. Do not assume the connections you're going to have to databases, to third-party services, to payment gateways, to search indices. Don't assume the domain name your application is going to run on. You don't know any of these things in advance. Don't assume that you can write anywhere to the disk arbitrarily. You can't. That's a security hole. Have very clear, narrow places that you can write to that is for data only. Don't assume third-party services will exist forever. They won't. None of them do. You need to be able to migrate. You need to be able to shift gears at a moment's notice when a third party decides to change things out from under you. And don't assume that your use case is big enough that you need to go full on microservices. Unless you are Amazon, Microsoft, Google, Netflix, you probably don't. Now, if you do work at those places, cool, go ahead and use microservices, but you probably don't work there And so don't try to model your system on what they think works for them. You are not them. Thank you. Thank you, everyone, for coming. I'm happy to take questions in the chat or wherever. You can find more about me at garfieldtech.com, or if you also do PHP work, go ahead and buy a copy of my book on functional programming in PHP. Yes, functional PHP is a thing. It's actually quite good. Or if you're interested in the new PHP 8, I have a free ebook available for that as well. Happy to take questions for as long as you got them.
Awesome. Well, thank you, Larry. While we just wait for any questions to come in here, I will move through some housekeeping stuff now, and then we can jump into questions. So again, yeah, thank you for that awesome presentation, entertaining as always. The next Jakarta Tech Talk happens on May 10th. We have Per Minborg joining us. He is the CTO and founder of Speedment, and he'll be presenting JPA Streamer, expressing Hibernate JPA queries with Java streams, and you can register for that session using the link I just posted in the chat. Jakarta EE has also extended the deadline for submissions for the Jakarta EE Developer Survey. We certainly hope you will consider providing your input to help the Java ecosystem and to help the stakeholders better understand the requirements, priorities, and perceptions of enterprise developer communities. And you can complete the survey by, again, using the link I just posted in the chat. As always, we are looking for more Tech Talks. So if you're working on a cloud native Java project, please feel free to sign up to present that and share it with the community. And that is the third link I posted. And finally, we always like to receive feedback. So I will post a survey at the bottom here that you can let us know how we did today. And I did see that we just had a question come in. And the question is for, I guess, me. Are you supplying a transcript of the presentation? Where can I go to download it? As of yet, we do not have transcripts of this presentation. I'm not sure if, Larry, you have one for yourself, but I guess, yeah, I can turn that over to you.
So the slides are already available online. I posted a link earlier in the chat. I can repost it if you'd like. So that's online now. The slides are all in HTML, so nice and accessible, and there's links to some other resources as well. My understanding is that a video is going to be made available later. If not, I've given this talk before in various forms, and there are links available on my website to previous recordings of it. That essentially the same talk. I varied a little bit each time.
Yeah. To build on that, we will be making this session available on the Jakarta EE YouTube shortly after this presentation concludes. And again, you can always revisit this presentation by using the link in your current browser, and you'll be able to watch the recording. I see we have a question that comes in from Carlos Herrera. He asks, what do you think about Docker and Kubernetes configuration and credential management, considering your point about safe/unsafe tooling approach?
I think they're kind of in an in-between area. They are open source, so worst case scenario, you can take your business elsewhere. You can get multiple Kubernetes hosts. You can get multiple Docker hosts. So that, in that sense, they're good. They are specific products of for-profit companies, though, so you do have to be a little bit careful there. The bigger point is your application should be independent of your containering system. I have seen applications that are built, mostly Ruby applications I see done this way, that they're built in Ruby and JavaScript and whatever, but the only supported way to run them is Docker. And the only thing you offer for people to run it is a Docker container. Don't do that. That is terrible. There are lots of ways to run software that are not Docker. Docker is not the end-all be-all. If you're using a cloud-based host, many of them are not based on Docker. Platform SH, where I used to work, did not use Docker as its containering system. There are more to containers than just Docker. But if your application is only available in Docker as a Docker image, guess what? You cannot run it anywhere that is not Docker-based. So that's a downside in a different way. If your application can run with an arbitrary container system and you tie it into Docker or Kubernetes for a specific deployment, that's fine. You can move those configuration settings to a different host if you need to, or if you move to a host that doesn't use Docker, you can port those pieces of the configuration to that new host without having to modify your application code. That's fine too. So, it's always a matter of giving yourself flexibility, options, and an escape route. That answers your question, I think.
Yeah, I think so. I think it was a good question and a good answer. Again, if you have any more questions, please feel free to get them in. We're just about to wrap up here. So again, thank you, Larry, for joining us today. It was a great presentation. And yes, please watch the recording on YouTube afterwards at the Jakarta YouTube channel, and feel free to register or sign up to present our next Jakarta Tech Talk. I'm not seeing any more questions. So again, thank you, everybody. And final word from Larry.
Word.
Perfect. Bye, everybody.
Be well.